right, thank you so much for coming, everyone. Happy Friday. Just to check, can everyone hear me and see my screen okay?
Yes, we can.
Okay, perfect. So hi, everyone. Welcome. I am Julie Gonzalez. I am the president of the Whitehatters Computer Security Club. On the call as well, we have Christopher Greenland, who is the vice president of Whitehatters Computer Security Club.
Hello, everyone.
And Today we'll be discussing CTF competitions, what they are, and kind of going over just kind of how to play in one. The reason why we decided to go with this is because in this virtual environment, it's really easy to do at home. You don't have to go anywhere to do these kind of things, and it's also just a great way to engage with computer security. So with that being said, let's get right into it. Um, So first of all, who are we as a club? So we're a cybersecurity club at USF, and we learn about all things cybersecurity, whether it be defense operations or even offensive security. Um, and using this knowledge that we kind of share with one another, we also compete in a variety of different competitions. Um, And Also, we do a lot of outreach events, such as summer camps, to teach local high schoolers about cybersecurity in the summer. Um, and so basically, as a club, like we just all have this passion for cybersecurity, and we just love to get together to learn it and then compete as a team. Um, so, what is a CTF? It stands for a Capture the Flag competition. Um, and this is referring to a type of computer security competition. Um, and so basically, it's a test of computer security skills. Um, and these usually revolve sort of a set of challenges that are provided by competition organizers that are given to us as competitors. Basically, they create these challenges that we as competitors basically try to hack into or break in some kind of way. Um, and by doing that, we're able to get a small piece of text that's called a flag. And then this kind of text we could submit to a website, and that gets us points if it's correct. Um, and so basically, kind of the whole idea is that the more challenges you complete, the more points you'll be able to get. And of course, at the end, whoever gets the most points wins that competition. And it should also be noted that the amount of points awarded is typically relative to the perceived difficulty of the actual challenge itself. So in many different CTFs, you will find that there is a range in terms of difficulty, as well as the actual skill areas that are being tested. So this is just kind of depending on which CTF you're actually competing in. There's a variety of different skills that can be tested because the actual field of cybersecurity is so broad. Um, so some of the examples that we're going to go over are reverse engineering, web exploitation, cryptography, forensics, steganography, and game hacking. Um, but this is not even a comprehensive list. There's also several different areas as well. Um, I know of one that is focused on social engineering, which is the kind of act of being able to persuade people into doing something that you want them to do or giving you a certain piece of information. There's also another one that is for open source intelligence, which is testing your ability to be able to kind of use the internet to do research on a particular subject. Um, so there's so basically what I'm trying to say here is that cybersecurity is so broad, and so there's different competitions that could test a different set of skills. One of these skills is reverse engineering, which is the process of taking compiled code. And this is code that has basically been compiled in a way that the machine actually understands it, right? And basically what you do is that you take that machine code and you convert it back into a more human readable format. And so usually the goal of a reverse engineering challenge is to understand the functionality of a given program such that you can identify deeper issues. So you would take this compiled computer program and you could probably find some way to maybe change it to give you a given flag, right? We also have web exploitation. So this is based around website security. As you guys probably know, websites all around the world are programmed using various programming languages. And within these different programming languages, there's different vulnerabilities. And there are just issues fundamental to the internet that can show up regardless of the chosen language or framework. And these vulnerabilities often show up in CTFs as web security challenges where the user needs to exploit a bug to gain some kind of higher level privilege. But it's not always just about the higher level privilege. Sometimes, like you'll find in web exploitation challenges, there's some little things that you could find out about a website where it just has leaked information if you know the right places to look, right? So this is one of the a really growing popular type of challenge because it's just so relevant today where you know, almost every single business has a website and all of these things should be protected, right? We also have cryptography. And cryptography is the reason why we are able to use baking apps, transmit sensitive information over the web, and in general protect our privacy. It is the practice of being able to encode pieces of information to kind of obscure what that information is, right? And so even though cryptography has a math base kind of as a part of it, because cryptography is using mathematical operations to generate ciphers based off the data you give it. Many of these challenges are just simply a test of your base understanding on how cryptography works, and that will allow you to find flaws and crack codes. There's also forensics. And forensics is the art of recovering the digital trail left on a computer. There are plenty of methods to find data which is seemingly deleted, not stored, or worse, covertly recorded. And so kind of one of the cool things about forensic challenges is that it could cover a wide range of different collection of computer systems. So one example I have is the analysis of network traffic. Some challenges, what they have you do is that they give you a capture of network traffic that was collected between communication between various devices. And you would have to analyze the actual information that is contained within that packet capture and be able to see kind of like where this information was sent to and from, what the information is contained in that network traffic, and being able to kind of put clues together and kind of see how you would be able to kind of find out different things through that network traffic analysis. Another example I have here is the actual analysis of computer memory. In one competition that I did, for example, we were given like an image of an Android phone, and we basically literally performed forensics on basically this Android phone that was infected with malware, and you're able to see kind of like all of the different apps that was stored on it, all the different photos, and of course the actual malware that was downloaded on it. And so this could be also a really interesting challenge, just because there's just so many different, again, cybersecurity is such a huge broad umbrella, and even under forensics, there's also a huge umbrella in kind of how you're able to basically investigate these computer systems and see what you could actually learn and extract from them, right? Kind of related to that is steganography, and it's usually the act of actually finding hints or flags that have been hidden within the steganography. Most commonly, you're given some kind of media file that's carrying some kind of secret, and then you'll have to be able to uncover what message has been encoded in that media. So the most popular example is photos and images. So you might have a picture of a cat, and that's all it looks like to you, is just a picture of a cat. But sorry, I got distracted by Teams. The actual photo itself might contain extra pieces of information that wouldn't be visible to you. So usually it involves a closer look into the actual data that's contained within that image file. And it might be based off metadata, or it could even be like something hidden within the bits of that file. So basically kind of the whole idea with steganography is that there's more to things than what meets the eye. And that's what makes these kind of challenges kind of fun. Oh, I missed the A there. Game hacking. Kind of another growing sort of challenge is game hacking. And essentially, how these things work is that as the challenge, you're given like an actual game that runs on your computer, and you literally hack it, and kind of seeing the different vulnerabilities that's within that game, you'll be able to get flags. So sometimes what you'll do is that you'll have this game file, um, and through that game hacking you do, you may allow your character to walk through a wall that it shouldn't have been able to. And then by walking through that wall, you're able to find the flag, right? So this is another kind of cool challenge. There's lots of different resources to learn about CTFs. We have great resources on our club's website at whitehatters.org under new members. And in a little bit, we'll also be starting a couple of different challenges together on Pico Ctf, which is a CTF platform developed by Carnegie Mellon for beginners to kind of learn about CTFs and practice those skills. So with that being said, does anyone have any questions?
These kind of things sound like a lot of fun. How would you say the best way to get started is? Like, would I need to have cybersecurity experience, or is it something literally anybody can do?
I would say that anyone can do it. And honestly, the best way to learn is to kind of do these things, right? With many CTF challenges, usually what ends up happening is because traditionally CTFs might run for a weekend, like 72 hours. And so at the end of each one of those competitions, the people who solve these challenges will do write-ups, right? And in these write-ups, they will outline the different steps that they took to actually solve the challenge. And so like if you had a challenge that you're stuck on, you're interested in solving, but you couldn't figure it out, there will always be a write-up kind of there for you where you're able to actually read through and be able to learn from that. And the other cool thing about that is that usually similar challenges may appear in the future. So during a CTF, if you're not sure where to start, you could always look up different documentation and write-ups that have been done by people in the past. And kind of one of the cool things about CTFs is that that's how you learn, particularly on the spot. So going back to my example about the Android forensics, like I did not know anything about Android. I don't even have an Android phone. I use Apple. So with that competition, we actually learned on the spot, like literally through research and just working together as a team. And we actually won second place in that competition. So that's one of the cool things is that like you learn as you do them, because kind of the whole point of CTFs, besides the competition and teamwork, is to actually learn new things that you wouldn't be exposed to otherwise. Are there any other questions?
If there are no other questions, Julie, would you have any questions kind of in review for our audience? We have a couple of giveaways we could give for anybody that participates.
Oh, awesome. So, so what I was thinking was that I was gonna, if no one wants to see the slide anymore, if you guys have the website jotted down, I could take it down now. But what I was thinking was I'll go on Pico Ctf, look at some of the challenges, and I kind of want the audience to kind of go along with me and see if they could figure out the challenges too, and we could just kind of work all together on these, if that sounds right with
That
everyone.
sounds great. Yeah.
Okay, perfect. I'll take this down now. Let me share. All right. Can everyone see this screen?
Yes, we can.
Okay, perfect. So this is Pico Ctf. As I said before, this is a CTF platform developed by Carnegie Mellon that is basically made to kind of help introduce people to computer security and CTFs, and kind of essentially you could kind of just use these types of challenges as practice. So what I was thinking was that we could go over some of the general skills, or if anything looks interesting to you guys, we could kind of go over it together. So we could start with this one warmed up. So yeah, does anyone know about the different ways that different numbers can be written, the different bases of numbers? All right, I'm going to take that as a no. So with numbers, you're able to write them in various different ways. Decimal is the one that we're commonly used to, and that one is also called base 10. Essentially, you just want to think of it as different ways that you could write numbers, right? Another way that you could write a number is in binary, right? So you probably know that as the zeros and ones. Base 16 is another way that you could write a number. And this number is written like this. So one way that you could just simply solve the challenge is to go on like a base 16 to decimal converter online and be able to solve it, right? Just for the fun, let's click on this hint. Okay, yeah, and for many of these CTFs, they do look for a specific format in how it's written. Yeah, does anyone know what this is written in decimal? No? All right, that's fine. So we'll just copy this. And then we'll do base 16 to base 10. Just one thing to note here is that in CTFs, you're like expected to use Google, right? You're expected to use Google Internet resources because kind of the whole thing is that you're learning like on the fly, right? So using online tools can sometimes make you successful in these competitions, right? So here we're using this hexadecimal to decimal converter, and we find out that the decimal number is 61, right? So we are going to do Pico Ctf. '61. Oh, I thought that I wrote that. All right. And awesome, we just earned our first 50 points, right? So let's try something else. Let's try a web exploitation one. So usually with web exploitation, they will send you a link to a specific website where you're able to just click a link to that website, and they might want you to exploit it in some kind of way. So, I should probably did this in a different tab. New tab. So here it is. We have this website, right? Cool. So one of the interesting things about challenges is that sometimes when it's written, they don't just give you the website, right? They might give you a little hint, right? So we were tipped off that the following code may need inspection. Does anyone know what that might mean?
If anybody wants to guess, you could be eligible for giveaways.
So let's see if we could click on the hints, right? So do you guys know how you could inspect web code on a browser? Let's see the second hint. There's 3 parts. Okay. So, just so you guys know, in many different web browsers, there's something called inspect. There's developer tools, and then there's inspect element, right? So if we go here to web developer and inspector, here we could actually see the website's code, right? So we could do inspector, and we could click different aspects of a web page, and then we could see the HTML elements that actually create that actual element that we clicked on in the page. We're able to see all of the little HTML snippets here. And if you click through, you could see kind of like the different code. And here we can see there's an HTML comment. So there's part 1 of the flag right there. We have that part, and I'm going to just write it down. So let's see if there's anything else on this page, right? All right. So let's click on this how right here. Okay, it seems to be the same HTML information. Let's see what else we could try. So it references this style sheet here and this JavaScript right here. So I think it's through storage, we're able to see, no, is it storage? We're able to see also the JavaScript and the CSS files. So it won't just only be the HTML. I actually haven't used this in Firefox. I usually do this with Chrome.
It might be under debugger.
Here it is. Okay. So usually in many of these developer tools, you'll not only just see what's actually on the page here, but also different other parts of that web page, like the JavaScript, which usually enables users to actually interact with the page, and CSS, which in web pages is used for actual styling of how the web page looks like. So that is stuff from fonts used, the colors, all those things are usually defined under CSS. So we could see this is the JavaScript, right? So we're actually able to kind of see what the code looks like there. And here we found part 3 of the flag. So in the HTML, we found part 1, and here we found part 2, right? You know what? I think instead of writing it down, I'm going to just copy. I'm going to just so we just need part 2 in the middle, right? So we found the JavaScript. Now we need to find where the CSS is. So through here,
It's probably going to be under style editor, I think.
Style editor. There it is. So okay, these different tabs, they correspond to the different aspects of the page. So the inspector allows us to look into the HTML. The debugger allows us to look into the JavaScript, and the style editor is where we look into the CSS, which is used for styling, right? So we can see all these different things are kind of defined here in this generic CSS. However, in my CSS, which is what's called in the actual page that we saw in the HTML, we could see this is where this user defined different specific things for the page. And here we found part 2 of the flag. So we could copy this. And then do that. And we earned another 50 points. Does anyone have any suggestions for any other challenges we should do? Anything that looks interesting? No? Okay, that's fine. So let's do this one. So it's asking if we could find the robots. And a hint. So what do you guys think this could mean? Does anyone know? Okay, so for websites, basically we all know about search engines, right? They kind of go through the internet and they're able to kind of catalog different web pages that are accessible to people, right? However, there might be some pages on a website that a creator might not actually want Google to be able to pick up and make public, right? So what they do is that they utilize a file called robots.txt, and in that text file, it will specify different web pages where it does not want those pages to be included into search results, right? So I should open this in a new tab again. So here it asks where are the robots. So sometimes you're able to just simply look up robots.txt, and here it is. So user agent here, it refers to any platform that you're referencing from. So sometimes it may be defined as an iPhone using Safari, or it could just be a simple wildcard character. And this means any single user agent, they should not be able to access this page. So now that we see what this is, we're going to copy. We're going to see what this page is. And we found the flag. And we earned 100 points. So is there any questions about that? About any of the things I went over right now?
A lot of the stuff you went over might not be familiar to a lot of people. If I want to do challenges but I get stuck, what would you say is a good place to look into? Like, did you say there were some resources on your website or something that might help us?
Yeah, so on our website, I could pull it up. So this is our website. and under our new members page, we have different resources here for different as like the different types of challenges we might find in CTFs typically. However, for Pico Ctf, because it's a very kind of high profile platform, I'm pretty sure that we could look at Pico Ctf write-ups. And there's several, right? If you, and I think if we wanted to, I'm pretty sure if you copy these challenge descriptions, it'll probably show up. Yeah, it showed Pico Ctf right there. And so that also helps. And so kind of with the Pico Ctf, it's not so much cheating, especially if you like you just don't know. Sometimes just the simple Googling can help you out, right? So that's just kind of like one of the cool things about Pico Ctf is just that because it's just like a public training platform, there's going to be a bunch of different resources that you could do just to kind of read how you would be able to solve these types of challenges, right? Does that make sense to everyone?
I think so, yes, thank you.
Okay, cool. So, let's see another one. Let's do this one. Glory of the Garden, and this is a forensics one. This garden contains more than it seems. All right. Or actually, we could open this. Okay. So we're not able to open this in mousepad, right? So there's definitely something interesting about this file, right? So sometimes you just cannot open every single file with a text editor like Notepad, because sometimes these files might be corrupted in some kind of way, right? So usually there's applications called a Hex Editor that actually shows you kind of the bytes of data to be able to kind of open up the actual file and kind of be able to play around with it to see if you could get it to actually open up. So actually don't know if I have a hex editor here.
What type of file is it, Jules?
What type of file it is? It actually went away. Let's see. Let's see. I'm gonna just download it again. It's a JPEG image.
Oh, this might be a stenography challenge then.
Yeah, probably. Okay. That's fine. I don't think I have the tools downloaded on here for that. But usually with steganography, you're able to look up different tools to be able to look at these kind of things. So I think if you do steganography tools, which we also have on our site here under steganography, there's this GitHub link which gives you like a kind of short walkthrough through a couple steganography challenges. And there's also different tools here that we have links to that you could then download onto a virtual machine to be able to solve these different challenges. And then it's just kind of like a game of putting it into these different tools and then looking to see if you could actually find anything in there, right? So let's look at this one. We did something like this already.
The previous one you would need a hex editor for.
Yeah. But I don't have one. I don't think.
Gotcha.
Let's see this one. Okay, so we went over hexadecimals before. So one other thing about hexadecimals is that there's conversions between hexadecimals and ASCII. Does anyone know what ASCII is? Okay, so ASCII is what allows computers to be able to display actual characters such as the alphabet and also various different special characters. And so basically you're in some cases you're able to convert from ASCII into hexadecimal or binary or numerical representations because ASCII basically maps characters of the alphabet to different numbers, which then the machine understands. So we could actually show ASCII table. So this is like an old looking ASCII table. Let me see if there's a better looking one. Okay, here it is. So this is one ASCII table, and as you can see, different letters of the alphabet are mapped to different numbers, and even like the numerical characters themselves are mapped to different numbers. And that's because that's when you have a machine that only understands ones and zeros, it needs to be able to map those ones and zeros to like different characters, right? And so ASCII allows us to do these things where we're able to have these character codes. So it asks us here, if we were told that it starts 0x70, and usually with hexadecimal, it starts out with the 0x. Like what would it start with in ASCII? So we would just have to find ASCII. And we find here with this tool that it's the lowercase p. So Pico Ctf. And we got it. So Chris, do you want to take over with going over the challenges?
Sure, I can look at a few. Let me share my screen. I'm sorry, I muted myself. Hey guys, so can everybody see my screen?
Yeah, we can.
Okay, cool. So I thought I would go, I have a hex editor on here, so I thought we'd go over this garden challenge. So to start with, we download the file, and it's a JPEG. Then we can open, I've already got one here, so we'll just open that one up. And I have a hex editor, so I'm going to go to open with, and I have HXD hex editor, which you can download for Windows. There's other hex editors for other platforms. Basically, every OS should have a hex editor application that you can use. Some other ones are like the Bless hex editor for Linux. I'm not sure about Mac OS, but I'm sure they have hex editors as well. So a hex editor lets you view the underlying binary of the file. You're not going to view it in binary, but it's represented in hexadecimal, which we talked about earlier is base 16. Binary, of course, is base 2. If you look at the file in its raw binary form, that would be really, really long and really hard to read. You would just want to go blind if you read something like that. So this presents it in hexadecimal, which because it's base 16, it can display a lot of information in fewer symbols and fewer numbers, if you will. In hexadecimal, there are 16, it's base 16, so you need 16 symbols to represent your numbers. So we use the first 10 digits of the regular decimal system, 0 through 9, and then we use the first few letters of the alphabet, A, B, C, D, E, and F. And those represent 10, 11, 12, 13, 14, and 15. So F is 15. So a hex editor lets you view that binary of a file. All files are really just binary. Even if they're a text file or a picture, they all have to be in binary for the computer to understand. When you're viewing a text file on your computer, you're viewing a translation of that binary back to something like ASCII or Unicode or whatever the text is represented in and encoded in. So a hex editor lets you view the underlying binary as hexadecimal so that you can kind of read it in a reasonable method of display. So another convenient tool is that this hex editor also displays the decoded text. So it will try to decode the text from hexadecimal into ASCII and show you that. So you'll see things like JFIF, which is forget the exact abbreviation, but it is basically the encoding for a JPEG, the joint photographic, no, photographic would be a P, but it's the people that, with encoding for a JPEG is JFIF. And we see some other information here, sRGB, which stands for red, green, blue. So this is just kind of the encoding that made the image. Hewlett-Packard is in here, so maybe this was made on a HP camera or an HP scanner, or maybe it was edited with an HP tool at some point. This is just the information about the photo. Sometimes you can find GPS information in here. Your phone, when it takes pictures, may encode GPS information into the photo, and that will be found in this type of information, and you can find it with a hex editor. But one thing that is common for easier stenography challenges is they will hide a flag at the end of the file, because you can hide some small amounts of extra information at the end of a file. So a good place to look is at the end of the file. This gibberish up here is just the picture information. It's trying to translate it as ASCII, but those are just symbols that don't really mean anything to us text-wise, like the ones at the beginning did. That's just the picture information.
Chris, if you're trying to show the hex editor, we could only see the Pico Ctf.
I'm sorry,
window.
I only shared the Pico Ctf window. My bad. Okay, I'll start over. Hold on one second. Let me just share the whole desktop. All right. Can everybody see a bunch of weird gibberish?
Yes.
Awesome. Okay, so as I was explaining before, this is the hex editor, HXD. I'm displaying the contents of the file, the JPEG file that we just opened, garden.jpg. And this stuff right here is the hexadecimal representing the binary of the file. This on the right side is the translation of that hexadecimal into ASCII. And some of that will be meaningful to us. Like we can see JFIF, which is part of the formatting for JPEG. We can see some stuff about RGB, which is red, green, blue, is the way that pixels are encoded. We see things like Hewlett-Packard Company here, which probably means that some type of Hewlett-Packard device was used to make this image. Maybe it was done on a Hewlett-Packard computer, a scanner. Maybe it's been through an HP. I don't know if they make cameras or not, but it could be. Like I said, sometimes you can find GPS information in here, and that could be part of a CTF challenge as well, as finding location on a map that's encoded in an image taken with the phone. But one of the most common things, one of the most common easy stenography challenges is to hide information at the end of the file after the picture. So we go down to the bottom of the file here, and sure enough, there's a flag. Here's a flag, Pico Ctf more than meets the I, and then they have a random number. So we'll copy that from the Hex Editor, go back to our Pico Ctf page, paste that in there, and submit the flag. Yay, points. So that's kind of just how to basically use a Hex Editor. And there are other features here as well, like you can find. So for example, one of the ways I quickly found that before was I just typed in Pico, because we know that we're going to look for a flag that starts with Pico, and I can search for it. And it can't find it, even though it's there. Well, it found it before. Maybe. Text stream Pico. Oh, I need to do all, probably. There we go. I was searching in the wrong direction. Okay, so you can find strings like this, and that may help you find a flag faster. Let's look at some other challenges. So what looks interesting? Let's try Netcat. Well, what's a Netcat? Okay, so this one is telling us to use Netcat in C, and going to be pretty important. Can you connect to at port to get the flag? Okay, so this is telling us to use a specific program called Netcat. So let me bring over a Linux terminal. All right, can everyone still see my screen?
Yeah, there's also
Okay.
a web shell to the side, just in case if you
snap.
want to use that.
Okay, I'm already here, but thank you for letting me know. Okay, so Netcat is a program that is used on the Linux terminal. There is a shell. Actually, I will show you the shell in Pico, because then you can do it even without a Linux terminal. Where's the shell, Jules?
So you see towards your
Oh,
right.
web shell. I see. Yeah,
Yeah.
there we go. Awesome. That's convenient. Okay, so this is a web shell on Pico Ctf. What this simulates is a Linux terminal, a Linux shell. So the Linux command line is very powerful for security purposes, for testing and doing these types of CTF challenges, because it contains a lot of familiar tools to security professionals. And that's why security professionals like to rely on Linux in their toolkit a lot. Some of these tools are available on Windows, and there are ways you can install even the Linux tools in Windows that you can Google around for and find things like the Windows subsystem for Linux, or I think Cygwin is one of the Linux terminal simulators for Windows, things like that. But Pico Ctf provides us with this shell, so it's very easy to get into that without installing Linux. So they are probably going to provide us with Netcat, which is run by typing in C. And then, let me see, I think I obscured challenge. Oops. Okay, I've opened it in a separate tab. That's good. Okay, we were on what's a Netcat, and they gave us this this address and this port. So I'm going to copy the address and go back to the web shell. Now, we don't know how to use Netcat, right? So one thing we can do on Linux is we can type man, that stands for manual, and then the name of a program that we want to use, Netcat NC. And that gives us interior Pico. Okay. That's random. I need to go get that. Hold on one moment. Oh, on my username, my bad. All right, well, that is not working for me right now. So I'm just going to go back to the regular terminal. So to find out how NC works, we're going to do man NC, and that gives us this little manual in the terminal, and we can find out how the command works and what options are available. And we know we wanted to specify both an address and a port. So here we see our source port. We probably don't want a source port. We want like a destination port. So port can be specified just by typing it at the end right here. And then our address can be specified just by typing it as the destination right before that. So press Q to quit the manual, and we'll type NC and then the address. And I think the last thing I copied was my password, so I don't want to try to paste that. I'm going to go back and get the address again. Okay. And some terminals like this one, you have to paste using Control-Shift-V, just an FYI. And then we have the port number, which was 64287. So Netcat is a program that is used to do basic text console input back and forth between two computers over a network. So what we're doing right now is we're connecting to a server, jupiter.challenges.pico.org. That's the URL for the server that we're connecting to. And then we're connecting to that server on a port numbered 64287. And you're on your way to becoming a Netcat master. And so this Netcat just gives us the flag right off the bat. Some other Netcat challenges might have you interact with the terminal in some way to get the flag. They might have you play a little game, or they might have you write some code that uses Netcat to solve some puzzles or something. Some will just ask you to solve simple mathematical challenges over and over again until it eventually gives you the flag. Others will have some kind of encoded flag that you need to decode with base 64 or hexadecimal or something to get the flag. So we can get this flag here, copy. And there we go. Okay. Anything else? Does anybody have any questions about any of the two challenges that I've just done?
If nobody has anything else, I'd like to thank Christopher and Julie for coming to present to us today. Also, thank you for all of our guests that came to watch the presentation. Don't forget to check out in the chat. Christopher posted some links to the White House or to the Whitehatters website, as well as the Pico Ctf and a couple other helpful links. Also, don't forget to check out the next couple live streams that we have at Expo. If you have any questions, let us know. If not, have a great day.
Thank you, Shannon.
Thank you so much, Shannon, and thank you to everyone who came.